Here in this question, we have a system of 3 particles each of mass m, which are kept at the 3 corners of an equilateral triangle of side A. This system is converted to a system in which the same 3 masses are at a distance 2a from each other on the corners of on the vertices of an equilateral triangle of side 2a. We have to find out the work done on the system so that the system goes from state 1 to state 2. Now this question can be directly solved using the formula using the concept of potential energy. The potential energy in state 1 of the object can be written as, for 2 mass system, the potential energy is equal to minus G m1 m2 upon r. For a 3 mass system or a multiple mass system, the total potential energy can be written as the summation of potential energy of each of the pairs. If there are 3 objects, you form pairs, that is number of pairs formed is equal to 3, C2 is equal to 3. So there will be 3 terms of potential energy, that is minus G m m upon r for these 2, minus G m m upon r again for these 2, and then again minus G m m upon r for these 2. So for multiple objects, the potential energy of the system can be found out by forming pairs, as many pairs as you can, and then adding up their individual potential energies. So potential energy in state 1 is minus Gm square upon r into 3. Similarly in state 2, the potential energy can be written to be, this r is equal to a, in this case r is equal to a, therefore this becomes minus 3 Gm square upon a. Similarly in state 2, the potential energy can be written as minus 3 Gm square upon 2a. So we know the potential energy of the 2 states. Now by work energy theorem, we have work done by gravitational forces acting plus work done by external equals change in kinetic energy, which is 0, since in state 1 and state 2, both the states, the system is at rest. Therefore the change in kinetic energy is 0. Therefore the work done by external forces, which we need to find out, is equal to negative of work done by gravitational forces. Now work done by gravitational forces, let us write it here, minus 3 Gm square upon a, state 2 is equal to minus 3 Gm square upon 2a. Work done by external is equal to negative of work done by gravitational forces. Now we know that the work done by gravitational forces can be written as negative of delta U, where delta U is the change in potential energy, is equal to delta U, change in anything is equal to final minus initial. So we write this as US2 minus US1. This is equal to minus Gm square upon 2a minus of minus 3 Gm square upon a, that makes it plus 3 Gm square upon a. This is equal to, this is 3, this makes it equal to 3 Gm square upon 2a. So the final work needed to be done by the external forces to convert the system from this state to this state is 3 Gm square upon 2a.